Hello, class. Okay, so today we're doing 7.5 sum and difference formulas. So these are just formulas we have to remember. Haha, just kidding. I'm going to give them to you. So let's just jump into it. I'll give you these formulas, but we need to know how to use them. So the sum and difference are given first, and we're going to look at this example. And we're finding the exact value of 75, cosine 75. And as you're thinking sum and difference, we can either find two angles that add, which is our sum, to 75, or two angles that subtract, which is difference, to 75. Here I'm going to use add, and you always want to use angles that are on our unit circle because that's what we know values for and can figure this out. So 75, the cosine of 75 degrees, 75 equals 45 plus 30. And 45 and 30 are both on your unit circle. That's why I'm using those and not like 70 plus 5. Because we have no idea what cosine 70 or cosine 5 is on the unit circle. So that's why I'm using 45 and 30, because those are on our unit circle. So this first number is the A, and the second degree is the B. And then we're using the addition one, the sum formula. So we're just going to plug this in to that formula. So the cosine of A, 45, times the cosine of B, which is 30, minus the sine of A, which is 45, sine of B, which is 30. Now I'm going to figure out what those values are. The cosine of 45 is root 2 over 2. The cosine of 30 is root 3 over 2. And then minus the sine of 45 is root 2 over 2. And then the sine of 30 is 1/2. So now I'm going to start simplifying this. So this first one, square root 2 times square root 3 is square root 6 over 4. And then minus square root of 2 times 1 is square root 2 over 4. They already have the same denominator, so I can bring them together into one fraction. So square root 6 minus square root 2 over 4. That's it for that one. All right, let's try this next one, and this one's in radians. So we have find the exact value of cosine pi over 12. And so we could use negatives to try and add to pi over 12, but instead of doing negative, let's do a subtraction, difference. And so just the difference between these two is that this one's now in radians and that one was in degrees. So if your problem was given to you in radians, you have to solve it fully in radians. You can't change pi over 12 to degrees and use degrees. You have to use the radians. So thinking of pi over 12, that's 1 over 12. So what minus what is 1? I'm going to go with 3 minus 2. That would give me pi over 12. Now, if I'm looking at 3 pi over 12, this simplifies to pi over 4. And then 2 pi over 12 simplifies to pi over 6. So we're finding the cosine of pi over 4 minus pi over 6. We're going to go ahead and plug it into that formula. I'm going to move this a little bit, as much as I can. Alright, so the formula is the cosine of pi over 4 times the cosine of pi over 6 plus the sine of pi over 4 times the sine of pi over 6. All right. The cosine of pi over 4 is root 2 over 2. The cosine of pi over 6 is root 3 over 2. And then plus sine pi over 4, which is root 2 over 2. And then the sine of pi over 6 is 1/2. So this would be root 6 over 4 plus root 2 over 4. They already have a common denominator, so bring them together. That's root 6 plus root 2 over 4. And that's our final answer on that one. So these top two equations are the sum and difference identities for cosine. So now we have ones for sine. So this first one is find the exact value of 7 pi over 12. And again, you can pick from either using addition or subtraction, but you want to try and find unit circle values. And I'm thinking of what adds to 7, which is 3 and 4. So if I have the sine of 3 pi over 12 plus 4 pi over 12, I would get the sine of 7 pi over 12. And then if I look at simplifying these, I get the sine of pi over 4 plus pi over 3. I'm going to go ahead and plug it into the addition identity. So sine of pi over 4 times the cosine of pi over 3 plus cosine pi over 4 times the sine of pi over 3. Sine pi over 4 is root 2 over 2. The cosine of pi over 3 is 1/2. Then cosine pi over 4 is root 2 over 2. Sine of pi over 3 is root 3 over 2. Multiply these. Root 2 over 4 plus square root 6 over 4, which is square root 2 plus square root 6 over 4. All right. We have find the exact value of sine 80 cosine 20 minus cosine 80 sine 20. So this one, if we look at this and we look at our formulas, we have sine, cosine, minus cosine, sine. So this is using that sine A minus B. So sine A minus B. And then if we look, that means A equals 80 and B equals 20. So if I put this in, sine of 80 minus 20, I get the sine of 60, and the sine of 60 equals square root 3 over 2. So you're recognizing that that was a sum and difference formula for sine and then working backwards. All right. Next, we are given these different items, and we're going to use these to find out A, B, C, and D. So we have sine A equals 4/5, and this is between pi over 2 and pi. So between pi over 2 and pi is our second quadrant. Here's theta, our angle, and the sine is 4/5. This is a special 3, 4, 5 triangle, and this is A. B lies between pi and 3 pi over 2, so our third quadrant. Oops. Draw that better. That's good enough. Okay. And this sine is -2 over square root 5. So I need to figure out what that other side length is. So I'm going to use Pythagorean theorem. negative 2 squared plus b squared equals square root 5 squared. So 4 plus b squared equals 5. B squared equals 1. Square root, b equals 1. And remember that's in the third quadrant, so that 1 is negative, and that's b. Alright, so in our first question, they're asking us, what is the cosine of a? And we're going to look then at our a triangle and just find the cosine. So cosine is the adjacent over the hypotenuse, and it looks like I forgot to put that negative on the 3. So, because that's in our second quadrant, and cosine is negative in that second quadrant. Okay, so looking at this, the cosine is using SOHCAHTOA is the adjacent over hypotenuse. So that would be negative 3 over 5. Now we're finding the cosine of b, which would be negative 1 over square root 5. Again, can't have that radical in the denominator, so we're going to multiply the top and bottom by square root 5 and get that this equals negative root 5 over 5. Alright, next we're doing the cosine of a plus b. So remember, we're going to write down the formula for the cosine, the sum, which is cosine A cosine B minus sine A sine B. And I'm just going to plug in all those values now. We have them all from A and B, and then what we were given in the problem. So cosine of A was negative 3/5. The cosine of B was, we could say negative square root 5 over 5. And then minus the sine of A, which is 4 over 5, times the sine of B. And I'm going to change the sine of B to negative 2 square root 5 over 5, so I don't have that radical in the bottom. So in multiplying these, I get 3. Let me move this a little bit. Oops. I get that this equals 3 square root 5 over 25 minus, and then it becomes a plus because there's this minus times that negative. And a negative makes a positive. And then 8 square root 5 over 25. When I add these together, I get 11 square root 5 over 25. Alright, now we're going to do the sine of A plus B. So let's write down the formula first. So sine A cosine B plus cosine A sine B. We're going to plug in those values. The sine of A is 4/5. The cosine of B is negative root 5 over 5 plus the cosine of A, which is negative 3/5. And then sine B is negative 2 square root 5 over 5. If we start simplifying, we get that this is negative 4 square root 5 over 25. And then plus times a negative is still positive. So plus 6 square root 5 over 25. And then I'm going to add these together and get negative 4 plus 6 is 2 square root 5 over 25. That's that. Alright. Next, we're going to establish that the cosine of A minus B over sine A sine B equals cotangent A times cotangent B plus 1. So I'm going to start with the left side. And I'm going to start with the right side because we have cotangent and cotangent, and we know that we can change these to sine and cosine. So cotangent would be the cosine of A over the sine of A. That's cotangent A. And then cotangent B would be the cosine of B over the sine of B. And then plus 1. Another way I can write 1 is anything over itself. And I'm looking at the left side, and the denominator is sine A sine B. So I'm going to use that same denominator, sine A sine B, so I can have this on that right side. And remember, anything divided by itself is 1. All right, next, I'm going to simplify, put together that left side to be cosine A cosine B over sine A sine B plus sine A sine B over sine A sine B. And now look, we have a common denominator, and we can add these together. So we would end up getting the cosine, let's put it higher, the cosine A cosine B plus sine A sine B. Start thinking of which one that looks like from up above for the sum and difference formulas. And then sine A sine B. All right. Let's see if you got it. It should be the cosine of A minus B over sine A sine B. And there we go. It matches the left side. Okay, last problem. We're going to use the sum and difference of the tangent formula. This one looks a little different, but we're still using the same steps, process, just different formula for tangent. Okay, so here we have the tangent of 19 pi over 12. So I'm thinking, what gives me 19? My first thought is 3 and 16. So 19 pi over 12 equals 3 pi over 12 plus 16 pi over 12. When I simplify these, I get pi over 4 plus 4 pi over 3. Okay? Those are both on our unit circle. So I'm going to go ahead and plug this into our sum formula for tangent. So tan pi over 4 plus tan 4 pi over 3 over 1 minus tan pi over 4 times tan 4 pi over 3. Okay, now I'm going to go put in all those values. All right, so the tangent of pi over 4 is 1. The tangent of 4 pi over 3 is the square root of 3. So 1 minus, and then that's 1 times square root 3. So then this equals 1 plus square root 3 over 1 minus square root 3. And you can't have that radical in the denominator, and when there's something with it, you're going to multiply by the conjugate. And our conjugate here would be 1 plus square root 3. You only change the sign in front of the radical. And so when I multiply these together, on the top I have 1 plus square root 3's now. So that's 1 plus square root 3 squared over 1 minus 3. And then I have more steps. Okay, I'm going to multiply 1 plus 3 times 1 plus 3. And that will give me 1 plus 2 square root 3 plus 3. And then 1 minus 3 is negative 2 in our denominator. Simplify the top. I get 4 plus 2 square root 3 over negative 2. And then here I can cancel or simplify these 2's. That 4 becomes a 2, but I still got to remember that negative from the denominator. And then, so this is going to equal negative 2 minus square root 3. And that is using this formula and fully